Hey everyone, in today's lesson from Unit 7 on circles, we'll be discussing arc length and area of sectors. A sector of a circle is a region bounded by two radii and an arc of the circle. So here's our arc from A to B, and then the two radii would be line segment AP and line segment BP. Now, two formulas you need for today are circumference of a circle, which is 2 times pi times the radius, and area of a circle, which is pi times the radius squared. Now, to find arc length, which is different than the measure is in degrees, arc length is in feet, or inches, or centimeters, or yards, or even miles. That would be a really big circle. But an arc is a part of the circumference of the circle, so arc length is a fraction of the circumference of the circle. So what you do is you take the angle measure and divide it by 360, and that'll tell you what fraction of the circumference you're dealing with, and then you multiply by 2 pi r. So in other words, our little formula, we're going to have A divided by 360 times 2 pi r. And again, this is equal to arc length. Now, when you're finding that angle, A, just keep in mind that that central angle A is also equal to the measure of the arc itself. So if you know the arc in degrees, just take and divide that by 360. All right, the second piece for today is to find the area of a sector. Now, it's an area, so it's going to be measured in inches squared, or feet squared, or centimeters squared, square units, again, because it's an area. And a sector is a part of the area of a circle, so the area of a sector is a fraction of the area of the whole circle. So in this case, you're going to take your angle, still divide it by 360, that tells you what fraction of the whole circle you're dealing with, and you're going to multiply it by pi r squared. So a little bit of a shorthand, it will be A divided by 360 times pi r squared. And again, this is for finding the area of a sector. So it's finding the area of, say, like one wedge of the circle. Think of it as a piece of pizza or a piece of pie. All right, in our first two examples, we're finding the length of arc AB. So we're going to take A divided by 360 times 2 pi r, because we're finding the length of the arc. So just to kind of highlight, in part A, we're finding the length of this arc. Part B, we're finding the length of this arc from A to B. Now, in both cases, we need to know the measure. So we look to the central angle. Since that central angle is 90 degrees, the measure of the arc is in 90 degrees. Okay, to find the arc length, we're going to use our formula. We're going to take our angle, which is 90, divide it by 360, and then multiply by 2 times pi times our radius, which happens to be 10 in this case. Okay, simplify that. So you're going to have to reduce some fractions here, but this one isn't too bad. 90 over 360 reduces to 1 over 4. And simplify the math over here. Take 2 times 10 and write it as 20 times pi. You can also write this as 20 pi over 4 and then reduce it. And when I reduce it, I end up with 5 pi. And this is the length of an arc. The units we're using on this problem are inches. And this is what we would consider to be an exact answer. All right, there's no rounding there. You're also asked, after finding it in exact form, to round it to the nearest tenth. So now you're going to go to your calculator, and you're actually going to take 5 and multiply it by pi. And when you do that, you end up with 15.7 inches. So this is really precise, 5 pi, and this is an approximation. But that approximation might make more sense, right? It might be more practical. All right, in our second example, we notice that the central angle is 60 degrees, so our arc would be 60 degrees. That's the measure, and now we're going to find the length. So we take that central angle, divide it by 360, and multiply by circumference. 2 times pi times our radius, which in this case is 12. Well, 60 over 360 reduces really nicely to 1 over 6. 2 pi times 12 simplifies to 24 pi. And when I rewrite that as 24 pi over 6, I notice that it can reduce more, 4 pi. If I just put it's centimeters. If I just put centimeters on my final answer, that's an exact answer. But if I take it and go to the calculator, that will be my approximation. And 4 times pi on the calculator comes out to be 12.6 when you round it to 1 decimal place. Okay, for our final two problems, we're asked to find the area of a sector. And notice it says find the area of sector APB. So we're trying to find this shaded region. All right, so everything all the way out to the edge of the circle, and including every little bit in there. Okay, the area of a sector, the formula is similar to that for arc length, but remember, we're taking a fraction of the area of the whole circle. So we want to take our A divided by 360 and multiply by pi r squared now. Again, look to the central angle, it's 90 degrees. So we're going to use an angle of 90 divided by 360 times pi times our radius of 10 squared. And then it's all about simplifying, simplifying, simplifying. 90 over 360 reduces to 1/4. 10 squared is 100 times pi. And then if you multiply these two together, you could write it as 100 pi over 4. And that's going to simplify to 25 pi. And be careful, it's got to be inches squared because it's an area. Okay, so the units have to be squared because we're discussing an area here. If you took and went to your calculator and you multiplied 25 by pi on the calculator, it would come out to be 78.5 square inches, and that would be an approximate answer. Like if you were doing something in the garden and you wanted to measure like how much mulch you needed, you might say the area was 78.5 square inches. That would make more sense than saying 25 pi square inches. All right, our last example, we're going to find the area of this sector, this piece of the pie, if you will. So we want to start by taking our angle measure of 60, dividing it by 360, and then multiplying by pi times our radius of 12 squared. Okay, simplify, simplify, simplify. 60 over 360 reduces to 1/6. 12 squared is 144, and put your pi on the end. So we really have 144 pi divided by 6, and 144 divided by 6 reduces to 24 pi. And this will be in centimeters squared. And again, that's exact. We didn't do any rounding, but now we're going to get the approximate area. And we take 24 times pi on the calculator, and it works out to be around 75.4. But it's still going to be in square centimeters because it's an area. Okay, good luck on the homework. Make sure you speak up and ask questions if you get stuck.